Hello everyone, my name is Raphael, and in this short video I'll be reviewing query optimization. The overall path is listed in 3 steps: parsing, optimization, and evaluation. Within parsing, the query is translated into its internal form, thus translating into relational algebra. Parser checks syntax and verifies relations. Within evaluation, the query execution engine takes a query evaluation plan, executes that plan, and returns the answers to the query. As far as understanding optimization, I would like for you to imagine yourself standing in front of an exquisite buffet. Your goal is to try them all out, but you need to decide in what order. What exchange of taste will maximize the overall pleasure of your palate? Query optimization is the answer. Once again, the query optimizer, called simply the optimizer, is a built-in database software that determines the most efficient method for an SQL statement to access requested data. The optimizer attempts to generate the most optimal execution plan for an SQL statement. Thus, query optimization is the overall process of choosing the most efficient means of executing a SQL statement. For example, Optimizer chooses the route with the lowest traffic conditions among all considered candidate plans. The optimizer uses available statistics to calculate traffic. For this reason, all SQL statements use the optimizer. The database optimizes each SQL statement based on statistics collected about the access data. The optimizer determines the optimal plan for an SQL statement by examining multiple access methods, such as full table scan or index scans, different join methods such as nested loops and hash joins, different join orders, and possible transformations. For a given query and environment, the optimizer assigns a relative numerical cost to each step of a possible plan, and then factors these values together to generate an overall cost estimate for the plan. After calculating the cost of the alternative plan, the optimizer chooses the plan with the lowest cost estimate. For this reason, the optimizer is sometimes called the cost-based optimizer, to contrast it with the legacy rule-based optimizer. An execution plan describes a recommended method of execution for an SQL statement. The plan shows the combination of the steps executing an SQL statement. Each step either retrieves rows of data physically from the database or prepares them for the user issuing the statement. An execution plan displays the cost of the entire plan, indicated on line 0, and each separate operation. The cost is an internal unit that the execution plan only displays to allow for plan comparisons. Thus, you cannot tune or change the cost value. Cost is generally measured as total elapsed time for answering query. Many factors contribute to time cost: disk access, CPU, or even network communication. Typically, disk access is the predominant cost and is also relatively easy to estimate, measured by taking into account number of seeks, number of blocks read, and number of blocks written. It is also noted that the cost to write a block is greater than the cost to read a block. Finally, data is read back after being written to ensure that it was successful. In this example, we declare 2 variables, T1 and T2. The first one is current date right now. ICD-9 is listed as the codes for diagnosis from DBO.DX age 2. Then you would group by diagnosis code and you would count by distinct ID. Then you would set the T2 against the current date. So you set the T1 as the current date. Let's say it's from 329. And the first one takes 1 minute to run. So the set T2 will be roughly 330. So 1 minute difference. And you would do select difference T1 and T2 of elapsed millisecond. It would be roughly 60 times 1,000, so 60,000 milliseconds, because a minute has 60,000 milliseconds, and then crisscross the index. So the T1 and T2 marks the time. You would run the query, then take what difference of the first time point with the second, so you just query how long it takes to run this. Yeah, so you have a time point which is T1, a time point which is T2. After the query is run, then you would take the difference in milliseconds, and you would do the same thing after you do a cluster index. A cluster index is a way to store / sorts basically the data within the table, and the values, for example, when you say create cluster index, it stores all the data in DBO.DX age 2 by ID and ICD-9. What happens is all the variables will go there and run. They will know when you start searching for something, and you would say count distinct ID in the query in ICD-9. So when the SQL algorithm starts searching for ID in ICD-9, it will go one by one, and it would make it a binary set. It would make it a binary set when you make a cluster index, because it knows how to sort it by this algorithm. So the search will be much faster. It won't go one by one. So what you are doing here is you're optimizing this to run faster for the same query. So you're optimizing the query speed because you selected ICD-9, and you count the IDs and group them by this. This will go through all the records to group them correctly. And so what you're doing here is you're optimizing this to run faster for the same query. You're optimizing the query speed because you're selecting ICD-9 and you count the IDs and then group them by this. This will have you go through all the records to group them correctly. But when you say create cluster index IDX, which is named by me on this table, DBO.DXH2, and the index is the ID with the ICD-9, the next time it will go and search it, because now I have an ID because now I have an index of ID and ICD-9, so I know exactly how to search them because it sorts them. Then next you would do T1 and T2 and take the elapsed milliseconds and see the difference. So if you have selected the above cluster, so if you select above the cluster, and run that and take the elapsed time, it would be 3, 4, 6, 7, and then select the bottom one and run it because it knows it and sorts it it sorts it for you. You exactly know what you're looking for, how to search for what you're looking for. So it gives you the ICD and the number of patients that have this ICD, and then the number of IDs for the given table and group. By ICD ensures you a unique ICD. You would get how many patients have this ICD. In conclusion, starting with parser and translator, when it is parser translated into a relational algebraic expression, as shown at the very beginning of this video, it is then optimized so it can be made efficient. And to optimize this, we use information regarding statistics. For example, how many tuple actually exist in the relation right now, and so on. Based on statistics, we will decide on an execution plan. An execution plan is how we actually want to proceed and what actions to take in terms of accessing the different indexes to evaluate the query. Finally, out of that, the query output will be generated. In conclusion, query optimization chooses the one that gives the minimum cost, and the cost is estimated based on statistical information from the database catalog. For example, number of tuples in the relation, the size of the tuples, the attributes on which frequently conditions are tested, and so on.